Therefore, z into z bar a real. Some say purely real. Also, we note that z into z bar is equal to x square plus y square. Now, in the form of x plus iy. Therefore, z by z bar, that is the quotient of a complex number and its conjugate. Quotient of a complex number and its conjugate is another complex number. Similarly, we can calculate conjugate of z by z, that will also be a complex number. Good morning, welcome to btosacademy. Welcome to my maths class. Today I am going to continue the topic complex number. In the last episode I started that, and formally I defined modulus and amplitude of a complex number. Before going to detail, let me first discuss few more things about complex number. First of all, few results related to a complex number and its conjugate. Few results. If z be a complex number and z bar be its conjugate, then also we take z equal to x plus iy. Therefore, its complex conjugate is x minus iy. Now we are going to discuss some results. If we add these two, what we find? Imaginary parts will be cancelled. Sum of z and z bar is real. By taking z, we have z plus z bar x plus iy plus x minus iy After simplification it will be 2x. X is real, y is also real. Therefore, z plus z bar 2x, which is real number. Therefore, the result is that z plus z bar is a real number. Then, difference. We calculate then after simplification it will be 2iy. Z minus z bar will be 2iy. Therefore, z minus z bar is purely imaginary. Next, we consider the product. Z bar, we calculate product will be x square plus y square, which is purely real. Therefore, z into z bar a real. Some say purely real. Also, we note that z into z bar is equal to x square plus y square, and we have seen modulus of z is root over x square plus y square. Therefore, z into z bar is equal to square of the modulus. And also we know if we take the modulus of the complex number, complex conjugate of z, that is z bar, that is also root over x square plus y square. Therefore, z into z bar is equal to mod z square, also square of the modulus of z bar. Next, number 4. We have considered sum and difference, then product. sorry, then it will be quotient. Already we have considered product. Now z by z complement, that means x plus iy, x minus iy. At the denominator there is x minus iy. To remove the complexity, we multiply both numerator and denominator by x plus iy. That means if we simplify, we shall get x square minus y square plus 2i xy divided by, we can express that now in the form of x plus iy. Therefore, z by z bar, that is the quotient of a complex number and its conjugate. Quotient of a complex number and its conjugate is another complex number. Similarly, we can calculate conjugate of z by z, that will also be a complex number. Thus, these are the results related to a complex number and its conjugate. Now, we have taken root over minus 1 as I. Now, what is the geometrical interpretation or geometrical representation of I? I am going to discuss it. Sound. Also, we can say representation. Now, I am going to represent z geometrical, or we can say geometrical interpretation of z. In the first part, I am going to discuss how I was introduced. For that, first I take the principal axis so-called principal axis, that is the x-axis and the y-axis. And students, already you know that x dash, x o x dash is called the real axis, and y o y dash, which is perpendicular to x dash, is y-axis. This is the concept of real number. When x, y are two real numbers, then the point x, y, x is the abscissa, y is the ordinate, is represented by any point. We say that point as P. Like this, where x is the abscissa and that x is the distance of P from the y-axis. If we draw perpendicular from P on x-axis and y-axis, then OA, which is equal to this length, if I call this PB, that is equal to OA, that is the distance of P from the y-axis, and Y, that is the ordinate, which is the distance of P from the x-axis. Already you have learned that in lower classes, that may be 8, 9 or 10. Now let us first discuss about I. I have taken a point A on the basis of suitable scaling. A, which is at a distance of x unit from the origin. That means coordinates of A will be x0, and A dash is another point lying on x-axis on the opposite side of A dash, which is at a same distance from O. Thus, coordinates of A dash is minus x0. Now, what we see? A is shifted to A dash, so that angular shifting is how much? Angle x o x dash, that is 180 degree. We can say that twice of pi by 2. Now, minus x can be written as already we have defined I square equal to minus 1. Therefore, minus x is equal to I square into x. Now, this can also be written as this can be explained as I can be taken as multiplicative operator. If we multiply I 2 times on x, we get minus x. And now we take angular shifting. Angular shifting is how much? Pi. Since A is lying on positive x-axis and A dash distance of A from O and distance of A dash from O same. Angular shifting is pi, which is double of pi by 2. Now, mathematicians have related in this way. If I, which is multiplicative operator, is applied 2 times on x, then angular shifting is double of pi by 2. Therefore, we can assume this, that if I is applied on x one time, then angular shifting will be how much? 1 time of pi by 2. This is an interesting similarity, interesting description. That means Ix will lie on the y-axis due to twice shifting of pi by 2. A comes to the position A dash. If I apply I one time, then A will lie on the straight line, so that angular shifting is pi by 2. That means that point is lying on y-axis. Let us call that point as A1. It will have ordinary coordinates 0, y. Now, as per this explanation, it will be IY. Very interesting explanation. Mathematicians have adopted this to explain I. Therefore, these things are discussed not on the so-called real plane, that is xy plane. The plane on which we discuss these things, that means complex number matter, that is called complex plane. Also called jet plane. Also, due to the name of the earliest mathematician who used this, Argand plane. Therefore, students, don't be confused about real plane and so-called jet plane or complex plane. Now, about the representation of x plus iy. See this diagram. I have taken a point P having coordinates x, y. Since it is lying on the jet plane, therefore it will be the complex number x plus iy. Now already I have told x is BP and y is AP. Therefore, P indicates the complex number xy if we use order pair or x plus iy. Now from this we shall define modulus and amplitude.